Hello everyone, it's Miss Thomas, and today we're going to look at division properties of exponents. So our objective is to continue to develop and understand the laws of exponents. So division properties. The first one is the quotient property of powers, and it's to divide two powers that have the same base, subtract their exponents. And so what this looks like is that you have a to the x over a to the y. So you can see the bases are the same, a over a. So then you end up just taking a to the x minus y. And so this is something that's sort of overthought. And this is one where I really recommend that you understand why it's happening and not necessarily memorize the rule. So if you think about it, if I have a to the 10 over a to the 6th, and I expand that out, this means I have a times itself 10 times. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And in the denominator I have a 6 times. Okay? And so we all know that anytime you have anything over itself as a fraction, because this is really just a fraction, that it equals 1. So that means this a over a equals 1, that equals 1. So all these a's over a's cancel out. And when I look, I have 4 a's left in the numerator. So I have a times a times a times a, which can be written in shorthand as a to the 4th. So just another example, we could have, we'll kind of change it up and maybe put 2 x to the 6th over 4 x to just x. So the thing that throws people off as well is the coefficients. 2 over 4 is just 2 over 4. Don't overthink it. If I gave you 2/4 over here and said simplify it, you could easily tell me, well, that's 1/2. So it's still 1/2. All we really need to worry about is the x to the 6th over x. So if you expand it, 2, 3, 4, 5, 6, end up with 6 x's over 1x. This pair of x's cancels out, and you are left with 5 x's in the numerator. So you end up with this 1x to the 5th over 2. The 2 is still in the denominator, but you need to be careful. You really don't need that coefficient of 1, so it's just x to the 5th over 2. So this leads to the idea of negative exponents. Negative exponents are another one where I want you to understand what's happening and not try to follow the rule. Think about conceptually what's happening. So a negative exponent tells you that you need to find the reciprocal of the base. And I put in parentheses here, only the base and not coefficients. So some examples of what that looks like, if you have a to the negative x, that is actually equal to 1 over a to the positive x. Conversely, sort of one example, another example, if you have 1 over a and then you have a negative exponent here, well, that means that the a will become a whole number and the exponent will become positive. You can also have where an entire fraction is being raised to a negative exponent. If the negative's on the outside, my suggestion really is flip the fraction. So make it the reciprocal. It becomes b over a, and then make this a positive exponent. So negative exponents, when you look at the sort of formulas for it, they seem really straightforward, but they tend to throw people off, so you want to be careful with them. Conceptually, what's happening with the negative exponent is, if you think about our first example, let's say we've got x squared over x to the 4th. Well, if I just use my quotient rule, And it's x to the 2 minus 4. I'm just subtracting exponents, which ends up being x to the negative 2. We're not allowed to have negatives in our answers, so it becomes 1 over x to the positive 2. The reason for that, and this is, just to be clear, this is the reason. If I were to expand x squared out, x times x, and then x to the 4th. So again, we have the same idea at work where the x's over x cancel out and you're left with 2, but those 2 are clearly in the denominator. People tend to be at a loss of what to put in the numerator, but remember those x's always have that coefficient of 1. So either way, you're going to end up with the same answer. I personally think it's easier to reason through it than to use the negative exponent rules. So power of a quotient. To find the power of a quotient, multiply the exponents in the numerator and the denominator. So what this looks like, if you have a over b to the x, it's the same as having a to the x over b to the x. So for example, I'll give you 2 examples. If I have 2 over x to the 3rd, becomes 2 to the 3rd over x to the 3rd. Remember, we want to simplify anything that we can. 2 to the 3rd, remember, it's not 2 times 3, it's 2 times 2 times 2. So that's 8 over x to the 3rd. Another example, if I have x squared over y, and that's to the 4th power, again, I want to distribute essentially that exponent. So it becomes x to the 8th, because 2 times 4 is 8, over y to the 4th. Okay, so now it's time for you to try. Your first problem is 3x to the 11th over x to the 5th. Your second problem is x to the negative 3rd. And your third problem is the quantity 1 over x to the 6th, all raised to the 3rd power. So remember, to get full credit, you actually need to try something on your own. Good luck.